The global consensus is that the best way to dispose of nuclear waste from power generation and other applications is to put it into deep geological isolation. Deep Isolation is the first company to develop a complete process for disposing of waste in deep boreholes. This video introduces our process. Nuclear waste, specifically spent fuel, from commercial nuclear reactors is made of small ceramic pellets of a compound called uranium dioxide. These pellets are held in long tubes called fuel rods, and the rods are arranged into bundles called fuel assemblies. The shape and size of a fuel assembly depends on the type of reactor it comes from. In a pressurized water reactor, fuel assemblies measure 30.5 centimeters diagonally and typically 4 meters long. Each fuel assembly can hold more than 250 fuel rods and 100,000 pellets. As of today, no spent nuclear fuel has been disposed of in the world. Spent fuel is still above ground, in pools or in storage casks. In Deep Isolation's process, we place fuel assemblies containing spent fuel into special canisters that fit into deep boreholes and are designed to prevent the escape of radioactive materials. Each canister is made of a highly corrosion-resistant nickel-chromium molybdenum alloy that will remain a barrier for containment of radionuclides for tens of thousands of years. Burying the spent fuel assemblies deep in the ground provides permanent protection from the long-lived radioisotopes that can be harmful for up to 1 million years. To ensure protection, we bury the spent fuel in rock far below the water table and where liquids have been out of contact with the surface from hundreds of thousands to millions of years. We start by drilling a larger diameter hole. For this video, we assume it is 91 centimeters in diameter and several hundred meters deep. A steel pipe, called a surface casing, is inserted into the hole. Cement is pushed down the casing and up the space between the rock and the casing, providing an additional seal. The cemented steel surface casing provides isolation from aquifers during the fuel emplacement process and provides a reliable, smooth conduit for canister retrieval. We then drill down several hundred meters and gently change direction of the borehole until it is horizontal. At this depth, the diameter is only 46 centimeters, just enough to hold the casing and spent fuel canisters. We will only dispose of spent fuel in deep layers of rock that are extremely well isolated from the surface and where isolation can be verified using established and proven geologic methods. Now let's go back to the surface and look at how we put the spent fuel canisters into the deep drill hole repository using standard drilling equipment, such as a wireline and tractor assembly, coiled tubing, or oil pipe conveyance. For this example, we have pictured a wireline and tractor assembly. The entire process above ground is done in a way that provides a safe environment for personnel and the public. The first canister is slowly lowered down the borehole. Deep underground, the borehole gently turns 8 degrees every 30 meters to the horizontal section. The spent fuel canister easily travels round this gentle curve without any distortion, a technique successfully developed over the last 20 years. Wheels on the tractor assembly help the canister move along the horizontal section of the drill hole. The first canister is in place. The tractor assembly is released from the canister and withdrawn. This process is repeated until all the spent fuel is in place. The vertical part of the borehole is sealed with rock and other materials. Within a few years, the enormous weight of the rock above compresses these materials and provides an excellent seal to the narrow access hole. Deep Isolation is the only company in the world with a demonstrated and patented solution for the deep geological isolation of nuclear waste using horizontal drill holes. A solution that is cost-effective, risk-averse, and available now.